Hello students, welcome to Misostudy, and today we are going to start a new segment for your better understanding of the concepts. And as it is clear from this heading, this chapter is semiconductors, a very simple and very useful chapter of your class 12th. And here we are discussing, we are planning to discuss JEE main pattern exercise. Here the idea is simple. By means of these videos, we want to provide good number of questions to all of you for practice, because we suppose that till now you must have completed your basic theory courses. Fine. And during the discussion of these topics in your regular video shoots, we tried our best at Misostudy to explain them in a very simple and useful fashion. So let's start this discussion one by one. A question will come, I'll explain you the question, and then systematically step by step I'll provide the answers. Here, on the basis of the analysis of JEE main previous year papers, just following that trend, we placed various questions carefully picked from various sources and also some formulated questions, fine, for your practice. So it's a collection of questions exactly based upon previous year's JEE main pattern exam. So students, let's start this discussion with this beautiful question number 1. Fine. In a p-type semiconductor, the acceptor level is situated 60 milli-electron volt above the valence band. Okay. The maximum wavelength of light required to produce a hole will be how much? First thing, this question is framed using the phenomena of semiconductors, but what exactly the idea and which type of formula you can apply, that I would like to explain you. So the idea over here is, let's say we want to give a simple diagram to this particular question. What is mentioned? Above the valence band, fine. So let's say this is valence band VB. Above it there is a 60 milli-electron volt energy gap, fine, and then acceptor level. Okay. So basically energy gap is given, that is 60 into 10 to the power minus 3 electron volt. Fine. We can convert it in joule by multiplying it with 1.6 into 10 to the power minus 19 coulomb. We are supposed to find out the wavelength associated with this particular energy value. Fine. So now you can say this question is simple, and the formula that you learned in photoelectric effect, that you can apply over here very easily. And what is that formula? That formula is E is equal to Hc over lambda. The value of H is 6.63 into 10 to the power minus 34, C is 3 into 10 to the power 8 meter per second, lambda value you have to find, and E value is 60 into 10 to the power minus 3 into 1.6 into 10 to the power minus 19 coulomb. What exactly the point of putting this question? Formula is simple, concept is simple. The only problematic part is calculation. Calculation is simple, but so long just because of these numbers that in general if you are not extra careful, you will commit mistake. Then if you just take a look of the options, they are same, just simple you can say difference in the placement of the decimal point. So a small amount of mistake in calculation ultimately give you a problem. These type of questions are asked just to kill your precious time, or they want to check how comfortable you are in calculation so that you can manage the time in the examination hall. My simple suggestion for this particular question is, listen carefully, some fast calculations that you have to practice. No scope for that, because no calculator, no device is allowed even to carry inside the examination center. Forget about examination hall. Fine. No mobile, no pager, no calculator, nothing. Even in JEE main exam, you cannot carry your own pen or pencil. They have to provide, they will provide, they provides. Fine, only admit card. So calculation, practice, and few terms you can remember. What are those few terms? Say for example, H into C is a value which is in general you used in your modern physics in these type of examples. So better 6.63 10 to the power minus 34 multiplied by 3 into 10 to the power 8. Remember that value, that final result after these two multiplication. So that will save lot of time. Fine. Now ultimately after this much sermon, let me mention the exact solution of this problem. That's just one or two steps I will mention, because it's my duty ultimately to explain which one is the correct option. Fine. So what I will mention, let me allow to use this space. Using E is equal to Hc upon lambda, lambda is equal to 2.07 into 10 to the power minus 5 meter. Simply multiply, divide and get the resultant. So from here you can say B is the correct option. Okay. So the first question, you can say it's a less question, more a suggestion. Fine. Now here comes a second question. Resistivity of semiconductor depends on. These type of questions you are bound to get in examination hall, and as such no specific preparation is required. Your normal understanding of the topic is more than enough. Let's say I don't know anything. Fine, but what I'll do, I'll start reading one by one these options. Accordingly we will try to find out the correct option. First, resistivity depends, it means conductivity, opposite of that. How better a conductor is semiconductor. How better a conductor is a semiconductor means if you have 3-4 semiconductors, which one is better semiconductor, I mean best conduct. So that way you have to define this. First is shape of semiconductor. Shape means circular, triangular, rectangular, elliptical. Is it like that? These aspects are important for the resistivity? No, not at all. So it means first shape is meaningless. It's not correct. Next, atomic nature of semiconductor. Let's say I have silicon, I have germanium. Both have 4 electrons in outermost cell. But valence band, conduction band gapping is different. Reverse voltage is different. So yes, atomic nature of semiconductor, it may be one correct option. Still I am not saying it is correct option. It may be. Fine. Let's move for C. Because in these type of competitive exams where negative marking is also there, unless and until you are not 200% sure, never mark your response. First, meaningless, no need to think. Second, may be possible, but let me check other options. Okay. Length of semiconductor. Length means what? Again, shape. Because we discarded shape, so length or any physical parameter, no role. Fine. Fourth one. Shape and atomic nature. But atomic nature is okay. Again, shape. So atomic nature alone is sufficient to decide resistivity of semiconductor. Shape, physical parameters like length, width, height, nothing is important. So now, without knowing anything, just on the basis of logical conclusions, you can say B is the correct option. Fine. So this is the approach, because you don't know which question will come in examination. ultimately you have to inculcate an habit where you can kill the question. Kill the question means solve the problem properly. Okay? Let us move ahead. If you will not kill the question will do something wrong to you. Okay? In a half wave rectifier, now here please wait. Actually, in these two previous questions, I started my discussion with the basic structure of a semiconductor, where I talked about valence band, energy gap, conduction band. In second question, what I explained you, again it was associated with the, you can say, microscopic property. But here I created a device. Once I created a PN diode, PN junction diode. Now that microscopic behavior, it means we have the clarity. So here we are going to use this device, half wave rectifier, one PN diode. The RMS value of AC component of the wave is RMS value of AC component. It means two types of components are possible. Basically what half wave rectifier is doing, you are providing AC, and half wave rectifier is converting half cycle of AC into DC, remaining half not available because it is half wave rectifier. If you attach two rectifiers, two diodes, and create a full wave rectifier circuit, as I explained you during the discussion of these topics in regular shoots, so that will give you complete DC. Half wave rectifier means for half cycle of AC DC, then no response, then again DC, then no response, and so on. Fine. So in half wave rectifier, RMS value of AC, fine, component of wave is equal to, more than, or less than. Obviously my half wave rectifier is providing me DC output, and what about its value vis-a-vis AC component, that we exactly want to find out. Now there are various type of losses and all these things, ripple factor and all this, which we explained properly. So I hope you have that idea, because you are regularly watching these videos. So here we can say RMS value of AC is more than DC value. You will say why? Okay, so first I will write down why. RMS value of AC is more than DC because of barrier voltage, this is something which just to explain you, fine, DC because of barrier voltage, fine, because of barrier voltage of PN junction, JUNCTION, barrier junction. So RMS value of AC is more than DC because of barrier voltage of PN junction. So now more than required, I explained, because barrier voltage PN junction, fine. This is a very simple explanation. So these questions you can say not difficult, fine. But just they want to check how much you are comfortable with your basics. Because in JEE mains, if you just pick various previous year papers, you will find from this segment definitely they ask questions, but they are you can say you can put these questions in the category of easy to moderate, not from moderate to difficult, easy to moderate. Even this year's question paper, one question was there and it was a very fundamental question. Fine. Here comes next question. A sinusoidal voltage of r.ms value of 200 volt is connected to the diode and a capacitor. This is diode, this is your capacitor in the circuit as in this particular figure. Fine. Initially I was thinking to draw the diagram, but I thought let us put the diagram so that there is no requirement of my intervention. So that half wave rectification occurs. Fine. The final potential difference in volt across C is how much? Basically, here if you just take a look, the peak value is like 200. This is average value 200 and you are supposed to find out the peak value. Fine. So, a simple formula is required here only, nothing else. Fine. What we have to find out? Final potential difference means P dot D in volt across C. Fine. I'm going to write down a basic result. What is that result? For, and here only one diode is present, so it's a half wave rectification. For half wave rectifier E naught is equal to E r.ms root 2. Fine. E r.ms value is given, peak value you have to find out. Let us put the values over here. So, it is 200 into 1.41 root 2. Once you multiply it and solve, you will get E naught as 283 volt. So, here important is this formula, this concept. Fine. For full wave rectifier, things will change accordingly, but one thing you are sure that by using this formula we can find out the peak voltage value. Okay. So, with this I think this question 3 is also a very fourth question, it is also a very simple question and as such nothing is difficult over here. That is why in the starting of this presentation I mentioned that this is going to be the combination of easy to moderate, sometimes slightly moderate to difficult type of questions. Okay. Here comes your first fifth question, slightly bigger one, and I do not want to come between you and your question, that is why I am taking slight different approach. I hope the entire question is visible to all of you. It is in which of the following figure the junction diode is reverse biased. Actually, these type of questions basically check your fundamental understanding of biasing of PN diode or even transistors. You need not to remember the circuit, you just have to understand the concept. First thing, reverse biased. Reverse biased means P should be connected to the negative terminal or low potential. I am repeating, reverse biasing means P means P type and should be connected to lower potential difference, -10, -20, which one is lower? -20. 1 volt, -2 volt, so minus, +1, -1, -1, -3, -7, -7, something like that. Okay. So, let us start analyzing. Which one is the symbolic representation of P type? Fine. So, now one by one, about option A, -7 volt, other end is -10 volt. nothing you can conclude. Something like that feeling? No problem, it's perfectly fine. Let's come on for this B. Okay, this is grounding, this is -10. What is the meaning of ground? Ground means 0. Okay, confusion in the mind. -10 one is less or 0 is less? Hold. Come on to this. 0 minus 10 volt. 7 and 10 volt. All 4 options. Which one is the correct one? Now, here I want to write down something. First I will write down which one is correct option, fine, and then I will explain you what I will say. I will say Y, okay, -7 -10. What I said? P should be connected lower potential difference. Okay. -7 -10, -10 is lower, -7 is not lower. So, in these two arrangements P is at higher. Talk about C, -10 and 0, obviously 0 is more, P should be at lower. Let us talk about D, +7 +10. Again, imagine the situation. This should be less, this should be more, while it is reverse. Only left option is this. So, do not say because A is incorrect, C is incorrect, D is incorrect, that is why it is correct. No, just take a look. -10 and 0. So, which one is more? 0. Which one is less? -10. Option is B. So, this type of logical approach, because 30 questions and 60 minutes, never ever jump for these type of questions. Otherwise, in general, after coming out from the examination hall, students like to say, oh my God, this is a blunder. This time many students, I mean this year 2018, there was a question about quality factor Q in terms of omega and L, AC circuit. Simple question they asked, omega given, L given, they asked what is the formula for quality factor, and maximum students devoted so much time. This is JEE mains question, it may not be so simple, let us wait, let us try to think. Simple question it was. So, these type of questions you just have to think, analyze and mark them. Do not think too much. How is it possible such a simple question they are asking? It is their right, they may ask simple, more difficult, abstract difficult, any damn thing, it is their choice. You can't decide, but yes, you can decide what is the correct solution by your approach. Fine. Now, here comes another question. In a junction diode, yes, about PN I am talking, the direction of diffusion current is what? There are few currents initially, I would like to mention them in junction diode, but because you have completed that chapter, so if I am saying IB, base current, you know, yes, base current is fine. Another, if I am saying IC, collector current, you will say yes, we know that. IE, you will say yes, it is emitter current. Then diffusion current, conduction current, you will say yes, these terms are not new for us. Okay. So, once these terms are not new for you, what is the direction of diffusion current in a PN diode? From P to N, from P to N, fine, or reverse of that, from N to P if junction is forward biased and vice versa if it is reverse biased, from P region to N region if junction is forward biased and vice versa if it is reverse biased. Now, please try to understand one aspect. Maximum number of students will find this question Oh, so confusing. Even till last moment they will not able to mark it properly, because same statement is twisted hence and forth and then represented. And you know, twisted facts are really very difficult to understand or to digest. So let's try to find out on the basis of the basic approach of this problem's solution. Fine. Over here I would like to mention direction, and why you people commit these mistakes I will also tell you, but first allow me to write down direction of diffusion current. Diffusion why I am writing, because now it is going to be the part of your this video. So at some point of time if you are watching this video, it may possible that this sentence directly goes into your mind. That's the reason I am writing this. Fine. Direction of diffusion current, I think I should use a different color chalk. Direction of diffusion current is from, now be very careful, is from P to N region, segment, zone, something like that. So now you need not to consider all these facts. Simple is from P region to N region. Now few of you may say, if this is so simple, then why you are creating some twisting and like this? Reason is, this simple line is mentioned in all books very specifically in the starting. But what is your tendency? First page out, second page out, third page a complicated diagram. Oh my god, this is something which is difficult. So all these important lines, specifically your NCERT books, each and every word is important. This question is just emphasizing that fact. While you are reading your book, please take a you can say pencil, fine, and mark these important lines, so that next time when you are revising this chapter, your eyes definitely comes onto those underlined pencil. Don't use pen, otherwise it's going to be very difficult for you to maintain the book. Fine. So this way if you prepare and if you read these type of lines 10-20 times, obviously in examination hall you will read like this: in a junction diode the direction of diffusion current is from P region to N region, because in your memory it is fed. Fine. So these type of questions by picking, I am just trying to show you what should be your approach. Because students, at any point of time, even if I am explaining you, I mean in Misostudy if we are telling you 1000 questions, 4000 questions, but if you don't have the clarity of the concepts, what it should be, what should be the approach? No use. Fine. So let's move ahead for next problem. Operating point of a transistor. This question again based upon the same phenomena or approach with the help of which I explained you sixth question. Now, moment you start the reading in your book, this transistor aspect, these type of important lines, important conclusions, you will start noticing. And your tendency is to ignore. Ultimately, calculation, ultimately difficulty in marks. Fine, put aside the calculation aspect. So let's analyze one by one. Operating point of transistor. I am sure you must have studied IB characteristics, that we explained also. So during that discussion these concepts are clearly given onto that text. So let me allow to mention something over here one by one how you can analyze. Operating point of a transistor is, one thing is clear, I don't know anything, but if you just take a look of the options over here, it is what? repetition. It means this much is going to be true, either A, either B, either C, either D. But how we will decide the second portion? Fine. Let us start discarding. IB, base current. The value of base current is very minute. Fine, very minute. So, 0 signal value, and that too by contribution of base current, not possible. It is 10 to the power minus 3 types of lesser than the value of emitter or collector current. Okay. 0 signal value of IC, collector current, fine. The value of collector current is obviously in the required zone, but problem is nothing is mentioned about voltage. And for the discussion of transistor, you have the clarity of not only voltage, not only current, but both. Now come on to the C option. As per the basis of this B option, you can again discard this option. Where is the current? Nothing is mentioned. So now the options over here are saying that only we are correct. Fine. 0 signal value of IC, collector current, and voltage, that to collector to collector. Fine. So these type of questions ultimately are in the examination paper just to check how focused you was during your preparation. Is it like that you observed each and every important segment of the explanation? Because in general you decide yourself. IV characteristics I explained, but is it like that if I ask a question based upon IV characteristics, it is possible for you to answer that? You will say, no sir, I need some revision. Fine. So ultimately this is the truth and you have to accept it and try to change your approach. Because these simple questions will definitely help you out to score very good marks, and that's why you can ensure a better rank. The ratio of work functions and temperatures of two emitters 1 and 2, 1:2. Then the ratio of current densities obtained by them will be how much? Now this question why I placed? Reason is simple. There is a one simple concept associated over here, that is why I placed this question. Let us say I have this surface, one surface, and I have another surface, say for example like this, okay, like this. Obviously thermionic emission basically is the idea over here, but we do not want to go into that details. A simple formula is there that I would like to mention, but just for the second listen. This is one surface, this is another surface. If I exposed both these surfaces with the same temperature, I mean same heating, it may possible one may emit electrons with some different energy, with some different number density, another may emit with some different energy and number density, because it is also the property of these two materials. So in that reference it is given, fine, two emitters, emitter number 1, emitter number 2. So what is the ratio of current density? From the understanding of photoelectric effect chapter, you know current densities means more number of electrons, that is number of electrons. So ultimately you have to find out with the help of temperature how you can assess about the densities, means number of electrons emitted out. So let us mention this basic result, that is current density. It is in generally given by J. Current density J is equal to A T square e to the power minus phi upon kT. Fine. Now this is temperature, this is area, this is phi, fine, and then this K this Boltzmann constant, and T is the temperature. So this is the general relation. Okay. Now change the area, current density will change. Change the temperature, current density will change. Now here is the catch point. What exactly the catch point? Temperature, if for one emitter is T, then for another emitter it is 2T, 1:2. So if the temperature is different, we have to use this formula twice. How? J1 upon J2 is equal to, nothing is mentioned about area, so let them Mr. A to go. Fine. T1 upon T2 whole square. In general, who will produce the problem? The problem will be produced by this exponential term. Reason, you can't cancel this term. Why? Because then it's minus phi 1 upon KT1 over e to the power minus phi 2 KT2. So simply you can't cancel it. You have to pick this value, put it upside. So it will be minus phi 1 upon KT1 minus shifted upwards, so it is plus phi 2 upon KT2. Fine. And then you have to solve these terms by means of the values given. Fine. So ultimately when you solve it, you will get it as T1 upon T2 is 1:2, that is square of it 1/4. So 1/4. Finally after solving it, you will get e to the power 0 and e to the power 0. So now answer is 1/4. Here the only thing you have to remember that this relation in current density, area, temperature is given by this formula. Now we are here supporting you not only for some specific type of you can say exams. Our idea is that you may preparing for some exams, someone is for BITS planning, someone is for some other exams. So the approach should be like that, you can handle, you can manage each and every type of exam starting from JEE advanced till any type of exams. That is why this much variation in picking these questions. Now here comes this situation. Consider the junction diode is ideal. Okay. The value of current in the figure is how much? Resistance is given, potential difference is given. Direct formula based question, no discussions required over here. So I am not wasting your time. Using V is equal to IR type of relation. Fine. I final is equal to V upon R. So it's going to be 4 minus 2. 4 minus 2 upon 300. Answer is with you. Simple formula, simple result, that is 0.02 ampere. Fine. Just because of some time constraint, students, in this particular question set, I am not able to devote lot of time onto logic gates, but I thought it's better that let's close this discussion with just introducing a simple question from the logic gates. And what exactly my point is? My point is, first there are these few types of gates you are supposed to know: AND gate, OR gate, then NAND gate, it's a combination of AND and OR, and then NOT gate, NOR gate. So first you should remember the symbolic representation, fine, and the Boolean expressions, okay, and some logical table output. This question is just a representative question. What is the output of Y? So it's a AND gate. Accordingly, you can say the output is, here it is NOT gate, here it is NOT gate. So B is the correct option, that is A bar dot B bar. No discussion is required as such, but my simple suggestion is please keep revising these concepts. So with this discussion of these set of 10 questions, fine, I tried to maintain the variation. I hope you will try to understand certain basic concepts which in this particular discussion I explained. So in future, be ready, I will come back again with some good collection of questions. Till then, keep revising, take care of yourself, have a nice time.